Yo, you saw the thumbnail and you thought let's learn something new, right? Okay, I think I'm going to teach you something new, but it's not for professionals, okay? It's just an entertainment that you might consider watching this video. So the title says that don't let data types fool you. Well, I mean it when I say that, okay? It's not a clickbait. It's definitely not. And it's for the beginners who just enter reverse engineering. It's not for professionals. I am sure that you already face these kind of situations all the time. But this is going to be for the beginners who just started reverse engineering and who just want to learn new stuff, probably for some kind of entertainment right now. I think if you're a complete beginner, let me give you a clarity check. Like most developers write code and that treat your privacy like your toxic ex. You know, they say that it's secure, it's encrypted, but they're actually just stuffing it your secret into a local folder. You know that no matter what code it is, it has to store your data somewhere in your code, right? In your computer. It's not a lie, it's not a myth. It just stores it somewhere. And there are a lot of clues over there that it shows that your data might be somewhere around this place. And that's what reverse engineering is. You're going to figure it out which place is that memories, and you're going to dissect it and know the secret behind. I mean, that's what developers say, it's secure, it's encrypted. No, it's not. I mean, 99% I'm sure it won't. Like, it's there like your toxic ex, you know, they say they will marry you, I don't know, they will love you forever, but it doesn't work like that. It's just a lie. So you probably installed Arsenix, probably you saw some cool desktop and Reddit, and you're just 6 hours deep into color panic and you don't know what's right for you. Your OS is treating you like a garbage, right? I guess that's where you are. But let me say this channel is all going to about reverse engineering, low level programming, and just doing some CrackMe right now. We're going to solve a lot of CrackMes in the future. We're going to take from the smallest one and bigger, you know, something that goes on tough. And I already solved it. I won't say that I didn't solve anything. I already solved one for you, and that's what this title gonna be. Okay, the first rule of your reverse engineering is that know your enemy first. Like, okay, let me go to this folder. Okay, check this out. I got a folder called CrackMe. I already have it. Look, it says that a dot. Let me read it for you. Look, it's asked me a username, so I will give you something like, okay, I don't know, like, it says it's wrong, right? So what do you understand this code? It says it wants a username and it wants a serial number. Right, that's what you first expected, right? You expect it, right? Maybe it's going to ask you, I don't know what's going to be. There are multiple possibilities over there. You might think, is it asking username? Does it have a particular username? Does it have a particular serial number for that username? We don't know that, right? We still don't know. So we're going to figure it out what's going to be. Let's check what the file content is all about. Okay, so it says that it's a ELF 64-bit LSP executable. Of course, it's a Linux one. And it's a dynamic link. Okay, it's not stripped. The first thing is, it just says that it's ELF 64-bit. In a human term, it's just a Linux native. LSB means the least significant byte. The first, because it's reading the memory from the left to right side. It's apparently too easy. The position independent executable. So if you don't know what I mean, this is what I mean. Position independent executable, PIE. This is the thing that can load anywhere in the memory to try and hide from us. So it's like a criminal with a fake identity. It means that it's like a criminal who can hide anywhere he wants. Okay, look, as I told you, it's not stripped. It's not. If you don't know what's a stripped and not stripped means, it's just like they left a map for us, you know. Probably with this, you might able to find the first stage of you. What's going to be a first step? Probably like, okay, let me check. Like, okay, look. You can see these are the strings that are left out in the program when it's compiled to assembly language or binary, whatever it could be. Check this out. Like, I think you can identify these kind of stuff like A to I, standard outputs, F plus, to lower, to upper, string copy, string length, and stdin. I think these are something I'm probably sure that you have learned somewhere in your junior high school. I don't know, probably depends on you. But if you consider what this is, look, this is a bullshit, okay? It's just bullshit. You can ignore it out. We don't need this. These are something generated after it's been compiled. So you don't need to think about it, but there is something you might want to consider thinking about. Look, check this out. Username must be between 8 and 12. Okay, it did ask us for the username. I mean, I wouldn't lie. We just saw that right now. The username must be between 8 and 12. So it means probably if you're providing a username that is lesser than 8, probably it will ask you to retype, to enter the username again, if I'm not wrong. and serial number, of course. So if the serial number was right, I think it would have shown okay, but we did got wrong. I mean, obviously we didn't solve it yet. Okay, I think we did figure it out what is all about. We just saw that there's a flirt, there's a put, and we also did see to lower and to upper. So it's converting the alphabets, probably any strings, to a lower and a upper, like uppercase of alphabets and the lowercase of alphabets. It could be anything. So we did figure it out. I think it is doing something with string. We did saw that there is a comparison between length and there is a comparison of, I think there is being copy, there is a string being copied to some other variable. It could be something like that. So I'm probably going to dump it. I think this is a, let me do this for you. Okay, so okay, this is a tool. It's called object dump. It just it just lets you see the disassembly of it. Check this out. It says there's a file format ELF64, 86, I think x86 and 64. So if you can see this out. So this is an assembly language, x86 and 64 bit. It's for processor, the processor that we use. There is ARM, there is like MIV. I think for different processor, different CPU, there's a different architecture, and different architecture comes with a different syntax of assembly. They are kind of similar, but they're also different at the same time. I think we shouldn't speak about that right now. We might want to discuss about it in future. So if you see, I think this is a ground truth. So when a program is compiled, this is what it looks like, because assembly was never meant for humans. I mean, it was kind of meant for humans, but it was never actually meant for humans. You could say like this is the part where it's this communicating with hardware. When I write something in C code, it can compile and it will transform itself into assembly binary. So that's how the hardware knows what it has to do. And you don't have to use this one. Like, this is just for you to understand. I don't want to make this video way too long. So we're going to dive into binary ninja. That's what I use. You could use Ghidra, you could use Cutter, you could use IDA free, you could use anything. That's on you. But I prefer binary ninja, and I do prefer Cutter sometimes. I'm in binary ninja right now. And look, it's already decompiled it to pseudo-C. Look, you can choose whatever you want. It says on the disassembly, low level. Okay, this is not for free one. High level. But we're going to do in pseudo-C. Okay, this is what we're going to do. This is much easier if you ask me. So I think I did tell you right how this assembly, how it looks like. Check this out. This is how it looks like. This is a ground truth. Okay, this is a ground truth. This is what a raw instruction is being given to computer. I mean CPU right now. So look, check this out. This is a part. Look, it's a 32-bit. It's a 32 one. It's giving like up to upper. I told you about this. I told you about the string. There was like to upper, to lower. Okay, that's the part. So we need to figure it out. What it's actually trying to do. So this is the part where it says username must be between 8 and 12. This is the part where you are giving out the serial number. I think this is the part where it's been getting stored at. Look, they both are different. Okay, you just can change the name. Like, I will do it in pseudo-C. I think when we're going to get more experience over it, I'm going to do a reverse engineering assembly. We're going to figure it out. I think a lot of people wouldn't recommend it, but we're going to do it. Okay, let's get back to pseudo-C. Okay, the birth one. Check this out. Probably I think this is user input. I'm going to rename it as a user input. Yeah. So, okay, check this out. This is a user input one. Okay, this is the string length. Check this out. So this is name length. This is the index one. I'm sure that I already done it, of course, but I forgot how I did it. Yeah, this is a transform name. Yeah, I had to remember. It's a name when it's get transformed. Yeah, this is the one. I want to explain it out. Don't worry. It's nothing special. It's nothing that much a complicated one. It's actually easy, Okay, this is the one that's being targeted right now. Check this out. It's a double. This is a targeted one. This is targeted city. Yep. This is the one. Okay, now I need to figure out this one. Okay, this. Oh, this is a provided one. You know, when I told you we have to give out a serial, so this is the one. This is what we provide in the user. You know, this is a provided serial. I think we already changed the name. What it should have been. I think we need to solve few of extra stuff. Okay. Okay, just changing a variable doesn't mean everything is solved out. Nope, it's just for your comfort. I mean, of course you cannot read what's a VAT 12H going to be. It's going to be way too much complicated for you to, when you remember those kind of stuff. Just you have to rename it. I think I would suggest if you rename it, because that's going to make it much easier for you to remember. So okay, I think I should add a comment over here. This is in hex, sorry, not hex. This is on hex, and you have to convert into decimal. Hexa is on hexadecimal, you have to convert into decimal. Not only this one, even this one. There are more probably, I'm not sure. Wait, this is I think I should make it something different. Change it. Okay, check this out. I'm going to convert it out. I just know what the value going to be. If you don't know how to do it, it's just way too simple, man. This is a 0th place index. This is the first index. So it will be 16 of power 1, 16 of power 0. You just have to multiply by this. That's it. Okay, that's it. So I'm going to add a comment over here. So you could add it wherever you want. Look, it's on new. You can just put it wherever you want. I think that's on you, man. Like, I'm going to add it somewhere here. Like, that would be something like, I think 136 byte, I guess. Yeah, that's what it is. I think this is the one thing I should know it. And this one, okay, this one going to be 128 byte. Sorry, 128 bytes. I think this is going to be 40, I guess. That's going to be 40 byte. If I figured it out somewhere else, we're going to solve it out later. Okay. I think we already renamed it, most of it. Because I'm going to explain you. I'm going to explain you how I renamed it. So how we figured it out. Look, I'm pretty sure. Let me say one thing that I forgot to tell you. Look, I use binary. Okay, I use binary ninja. If you use something else, you might get different. You might get a different decompiled pseudo-C. Look, I'm going to show an example right now, right here. So I'm going to take a new workspace, and I'm going to search out. Look, check this out. Cutter. Look, I'm in Cutter right now. I already kept it in one workspace. I thought I would show you later. But if you see out here, we are getting a slight different one. Look, it's not same. Look, a single logic can be written in different way. Right? It's 1 plus 2 is also 3 and 2 plus 1 is also 3. Like, it could be written both way. It just have to be like that. You can just do it somehow you want. Like, you can do 5 minus 2 is all going 3. Like, you can bring out the value 3. You can do it in you can just do it like 3 into 1, 1 plus 2, 2 plus 1. You can do however you want. Okay, this is the same thing. So decompiler can write your pseudo code like C on different ways. It could be anything. Look, in binary ninja it shows me something different, and over Cutter it shows me different. So if you're going to use something else, like you could use something Gidra, if you use something else, don't get scared out. Look, logic is the same thing. You just have to figure it out. That's it. It's going to be easy. You just have to be smart enough to understand how it's going to be. Look, check this out. Look, if you see this part and if you see this part, they're way too similar. You know, just I think they are a little bit of different, but the logic is same. Look, the logic is same. You don't need to check this. This line, the canary, the stack canary, we just got it on the head. Just check this out. It's here. It's the same thing. It's the same thing, you know. That's it. You know, it's way too easy, man, that you just had to figure it out. And I'm going to show you how to do it. It's nothing much of a serious over here. Okay, now let me help you out. How does this work? So, okay, no more wasting the time. Before anything, you just need to know some of this stuff. So, I told you, right? I told you there's a canary. It's a stack canary. So, what is a stack canary? So, if you heard, I think since you came into reverse engineering, I'm pretty sure that there is a concept called buffer overflow. If you meant to carry 100 kg and if I give you 150 kg, you cannot carry that out, right? You're going to break yourself. So that's exactly what a buffer overflow is. If a string is given more than it should have been, more than a limit, it's going to break out. So that's what it is. So how does a stack canary going to save you from this? Look, I think I could give you a good metaphor, like example, like imagine there is a front door in a old coal mine. A miner kept a canary in a cage, and if a toxic gas leaked, the canary would die first, right? Because they just put it in a cage, and the birds are forced to sense those stuff. So the canary would die first, and it would make sure to give a warning to the miners. Like they would think, okay, I need to get hell out of here, or I'm going to die, right? So this is what a stack canary is. When the value is being altered in a canary, the program going to get terminated, so that the hackers don't misuse. So that's why stack canary was built. I'm pretty sure you might be wondering what is FS is. So FSGS, we're going to learn it on the next videos probably. But if I had to give you what the simple basic idea of what FS is, FS segment is like a master vault in a different part of city. Assume it. Every time the program starts, it generates a random secret number. It's our canary, and it places it right at the exit of a function room. So the code will be like, before the program is allowed to leave the room and return, it checks if the canary is still alive. If the number is being changed, it's going to terminate. Okay, I already told you. So what's the attack going to be? If a hackers try to get overflow buffer into the house, that's what a metaphor I gave you. To react the secret home, they have to step out and they crush the canary first. And the program sees the program will see it. Okay, the canary has been crushed, and it's going to self-detonate before the hacker can take control. So that's what canary is. I think the next thing we should know is this fget. Fget. So what's fget is? So I think I could give you a good metaphor. This one. Imagine there's a security guard with a measuring tape, and imagine there's a nightclub only has a room for 180 people. Now the regular it gets old lazy guard who just lets everyone in. If a 500 people shows up to the club, it's going to collapse, right? I mean, there's just 128 rooms, man. How would you expect them to give the 500? So this is how buffer overflows happens. I told you, right? If you give something out which is out of your limit, it's going to collapse. So fgets is a professional guard. Okay, you tell him that only let 128 people out. If lines of 500 shows up, he count exactly 128, and he going to shut the door. Like, no, 120 has been done. Okay, just get the hell out of here. That's it. So it says, look, fget is saying like, okay, this is where you should input is coming from. It's going to 188 bytes, and it's an input. Okay, this is what I'm saying, so that the buffer overflow doesn't happen. If you see when we just getting the string, when we were checking out the code, we did see it says that user must be between 8 and 12, but every time we get just whole number of string, it's just repeating it again and again and again. So this is what it is. Okay, let's go to the next one. I think next one is where it's being compared, right? I think okay, now what it's trying to do is I can give you a good metaphor for this one too. Like imagine there's a customer office looking for a counterpart. When you type your name and hit enter, the computer sees your name plus a new line, like a character, the string. This part, what it's trying to do is, it's like a custom officer at the border who has a list of forbidden items in this code. It searches your name in the next line, and once it finds the position of the character, the program uses the info to replace the next line with a 0. It's called the null terminator. It's basically a chop of the entry key so it doesn't mess up the logic later, something like that. At first it's like a flushing out the pipe, man. Like imagine you're writing a letter and you're just keeping the words out of your head instead of putting them on the paper. The computer uses a buffer to save time. When the program says a printf the username, it might just sit on the pipe. It shows up on screen immediately. It doesn't let the bowl to be completed. It just flows it out. Like you got the username, okay, move on. That's it. Your limit might be 128 bytes, but you don't have to wait till then. You just got it, just move out. That's it. It just also prevents the overflow. You know, all this stuff is just to prevent it out. The canary, the fget, the flush, so that they don't misuse. I think if there was a buffer overflow, it had this challenge might have been much more easier. I think we just have to move on to the next one. And you can see this is a part where it's being compared. You know, the name of the length, the string length should be more than 7. Let me add comment to this part. I think 0xc is equal to, I think 12, right? Yeah, it's a 12. Okay, we're going to move on to the next part. Okay, just don't worry. Okay, this is all the same thing. You get the serial number and you're just going to be approved over here. Okay, we did figure it out. Okay, we did figure it out how username is working. I think it's the time we figure it out how serial number is working out. So same thing, there's a loop. Okay, this if statement, you can read it out. This is on human readable form. Okay, I want to explain you what is the main concept over here. So I will not waste you much of your time. So here you can see that it is follow the same rule as username. Okay, at least till here. But in this part, there is something special is going on. So the explanation is the 0xc, it's a 12 byte, right? So after the decimal, the 10th will be A, B will be like A, B, C, D, E, F till 15. The value till 15 moves on. So C is 12. This is a gatekeeper. Your name should be between 8 and 12 characters. So if you use failsafe, that's an 8 character. So it's just right. You know, that's enough. But the serial input in if condition, check out this line. The explanation is if means a long float. If it's asking for a 64 double, this is the start of the data type. Okay, this developer wants you to think that the serial is complex decimal, but it's not. Okay, this is not. This is called, some people call the zebra loop. It's a transformation part. That's why I just named it transformation name. I know it's just weird, but you have to go with it. So this is a main concept where your name will get transformed. This is a part where you're going to get transformed. The name will get transformed. How we're going to get transformed? We did saw a few of the leftover strings in a non-stripped, where we were reviewing the file content. So what is those files? So we did see to lower to upper, right? Okay, this is where it's going to be. I think this is the interesting part. I think this logic is pretty good, man. If you ask me, it could be a little complicated, but it's actually good. It's actually good. So what it's trying to do is explanation is that there is an odd one. Okay, it's an odd one. This is an even one. I just mistaken. Okay, just ignore this comment. I'm really sorry about it. So it checks. Look, it just checks. If it's 1, it checks the last bit of the index. If it's 1, the number is odd, right? But if it's 0, it's even. So let's assume that I'm going to. Okay, let me open up terminal. Just text. I'm going to put. It's a face. This is what I gave it, right? So the F, the index 0 is even, so it would be F. But A, it's odd. A is odd, so it will be capital A, because it just moves out to this part. Check this out. Okay, this is the part. So if the value is odd, it's going to get upper. 1 is an odd number, 0, 1, and it's odd. So same thing will go for like I, that's even, that will be I. L is odd, so it's going to like this. Same for safe, like it's going to be same for everything, something like that. So a small, a big one, a small, a big one, something like that. I know it's not a suspicious. Okay, don't think anything bad about this when I say small, big. It's a trap buffer. You can say it's something like a trap buffer. Now you find out that okay, the value has been transformed. So the failsafe, what I gave as an input, is being transformed through a logic of even and odd, where the value, when the value is odd, it's getting to upper. So it's in a caps. But when the value is even, the value is being transformed. The kata is getting transformed to the lowercase. So eventually we're going to get failsafe, but in a different format, right? When you get a lower one and a upper one, the lower one and upper one through the index. This is it. Look, this is going to be stored somewhere out. Check this out. This is it. Okay, the next thing we need to figure it out is that the string is being this is line that I'm going to explain you right now. This is a main part, okay? This is a main part of the program too. Even you have a name is a 12 character, the program going to copy the first 8 letter. It's like cookie cutter, you know, it's like a cookie cutter. It doesn't matter. It doesn't even fucking matter if you have 128 bytes of letter. It's going to just take the starting 8. That's it. See, that's it. It's just going to take the 8 from this to this. There you go. The reason I'm going to show this out is because it doesn't matter, man. Like, even if you give 128 characters, it's just going to consider the starting 8. This guy is genius, man. This guy didn't. I think this is a really a good thing, you know. If you're starting out with this one, I think it's going to teach you a lot of important concept. I think you just deserve a shout out, man. I don't know who made this, but you just did a good job. I just got it from the CrackMe, to be honest. Okay, the next, I think we figured it out this one. I think it's time to figure out this one too. No, this one. We're going to figure out this one. Okay, this is a double one. It's a double derive. So it's a high precision one. So you could ask like, why would you use double? Why not use float? Because that's a 32 bits. It's a 64. It's a high precision one. So that's the reason we would use it. This is the core of a title. Okay, the A to I takes a string, the failsafe. Though, you know, when I said the failsafe, you know, the capital and the lower, the mix of both, and tries to find a number. Sees if F gives up and returns a value 0. No, it doesn't return anything, because why would he even return, man? It's a character. It doesn't return anything. So it's cast out that 0 into 0, 0, the high precision. The series is just a big fat 0. The final verdict, this is a float compare unordered. Okay, explanation is that is unordered checks if the number are valid or not a number. If the value aren't equal, it prints wrong. Since our target serial number is 0, if we type 0, the prompt going to be 0, the condition is false, so we're gonna get the else branch, that is okay. And now we're going to discuss about this one, I guess. The program does check one last time. It compares the current canary to the original one. We did in the step 1, right? This is the part I was talking about. Okay, it's going to check for the last time the current canary to the original one we saved for the step 1. If they match, we're going to exit gracefully, and if we messed up the memory, the program going to blow up. That's the stage 3. This is a key gen reveal. So I think this is the logic has been exposed. The developer used a double to look fancy, but A2I made a serial weak. To be honest, that's what it did. If you use the same failsafe, and the answer is going to be 0. If you use 1, 2, 3 test, the answer going to be 1, 2, 3. Because the data types were a lie. Okay, that is the reason I told you, don't let data types fool you. There is a A to I. Okay, I will say it. There is a A to I. Look, check this out. There is an A to I, but the answer going to be 1, 2, 3, because data types were just a lie here. Look, I know you might not believe me right now, but when I say something like this, but I can show you, man. I'm not lying. Look, I think I do have I did write. Check this out. Look, this is the same part. Okay, this is just the same part. I already saw this. Obviously I did. What I did was I just took this same logic and I just rewrote it in Python to figure out what's going to be the serial number for every input I'm going to give it. Every input I'm going to provide for this. So let's check this out. Like Python 3. Okay, so it's going to be, sorry, the serial number is 0. Okay, and I did tell you, right, what if it's going to be 1, 2, 3 test? It's going to be 1, 2, 3, 4. That's it. So we're going to try it out. Look, we're going to try it out both if it's true. So I will fail safe. Say it is 0. Yeah, so it's right. If I do 1, 2, 3, 4 and test, 0 should be 1, 2, 3, 4. Yeah, it's right. See. Look, I could show you this how I wrote it, but it's going to take too much of time. That's the reason I will not talk about it right now, but we would talk, maybe I will make a video on future how I did it, so how you can do this. That is all, man. Just, it's way too easy. You just have to figure it out. I can just make a whole bunch of huge videos out there, but it's just going to be a lot of wasting of our time. You know, I could explain every bit of line, but I don't think it's worth it, man, because my explanation would be different for you too. Okay, here if you see properly, where was the shit? Check this out, this one. So you should have seen that. You should know. I just noticed late. Okay, I promise you, I just noticed it late. So this is an OR operator. It's a security guard for who only needs a one reason to kick you out. So if your either side is true, you're going to get a wrong one. If the message to get okay. If you have to make a both side false, the Y float, you know, the floating point number have a weird shade called as not a number. If you try to compare a normal number to a not a number, the computer doesn't know what to do because it's an unordered, right? So the logic is, since our target serial is clean 0.0 from A to I, and the provided serial is a number that you typed likely a 0. So both are valid number. The result is unordered and is false. So it's a 0. So false is 0 and 1 is true. So the targeted serial, the provided serial, you know, the technical side, this is a standard is a standard part. So result, since they are both are equal, the statement they're not equal. So it's a false one. So OR operator, man, I think this is a basic one. Look, I can speak about it, but you just have you just have to learn C. You know, to do reverse engineering, you should know a bit of C. You should know how to read a bit of assembly language, and you should know Python for automation. Look, I just showed you, right, how you could use Python. You should know that one too. So I think the video is way too long. To the next video, we're going to talk about the zebra transformation. We're going to talk a lot of stuff. Okay. So thank you for watching this video. I think we're going to meet on the next video. Next video going to be probably the buffer overflow and stack canary. We're going to do video on both of it. Okay. That's going to be short video. I'm pretty sure that you still have a confusion about what is stack canary, what is this shit. So we won't waste our time. We will make a video on that. Okay, thank you.